Okay. Hello, everyone again. I hope we can start. I think the others will be joining us. Mm. Thank you, Maureen, for that. Yeah. Okay. My name is James. So, for those who are joining us for the first time, this is the LangChain Community Kenya. It's a community focused on LangChain as a product where we try to experiment with the product, build some prototypes, and learn from each other. So before we start, today we were to have a guest, but to make it to the meeting, but and I'll start by video. So you guys will let me know whether you'll be able to hear the audio. Are you able to hear? Okay, I think I'll share the video then so that you can listen to it. Then, yeah. Okay, so to look at what's new on LangChain and LangGraph version 1.0. So they released a new version. So we are going to have a discussion. We used to have some lessons like building a lag agent, building some agent, bot agents and stuff. But for today, it should be a discussion. So in case I miss something or you feel there's something that I've left out, you can just unmute, then you can have the discussion, or maybe you can take us through it. So to start with, I'll give a journey or a history about the LangChain ecosystem. I feel this will help paint a picture and of what's new and make us easily understand what is happening behind the scenes. Okay, so around October 2022, this was a month after OpenAI was released. LangChain was released by Harrison Chase as a Python package, and at the time it offered two main components. That was the LLM abstraction and building some chains. So that was the early stages where you could build just you could do a simple LLM abstraction, combine with some chains, maybe build a simple RAG, then that was it. Then after that, around 2022, that was December, there was a paper that came out called the React paper. So React stands for Reason Then Act. So the paper came out, then that's when now LangChain now adapted the paper, and they did their first multi-purpose agent. So what the paper was about is that you could generate a JSON using the LLM. Then use that JSON, feed that into an API. After invoking the API could return some data. Then you could take this data, feed it back to the LLM, then get some results. So now that means that it's kind of we're creating a loop where the LLM generates the JSON, we feed that JSON into an API, we get the response from the API, then feed it back to the LLM. But at this point, OpenAI was in the early stages still. So, and at that time, you could only send a single string, like a string of characters. Then the API could return back a string of characters. So in January 2023, OpenAI releases a chat completion API and some other models like now the Google, the Anthropic, they also adopted the same design. So the difference with the what came with the chat completion API compared now to the previous one was that with the chat completion API, you could send a list of messages and get back a response like a single string, a string of characters. Adapted this 2 months or 2 months after that. That was in 2023 March. Then OpenAI releases the function calling on the API. And the one of the major reasons why they did this, I think, is because of the React paper, because now a lot of developers were now generating the JSON using the LLM and sending that to API. Then the API return the result, then you feed that into LLM. So it kind of became like a need. So OpenAI decided to support this natively on their API. So after they released the function calling, LangChain also adapted this. And actually now this was the preferred method compared now to the JSON one, because this now was supported natively by the API. Then almost 1 year after the function calling, the chat completion API, then the LangGraph was released. And this is what I need us to understand so that what's new with the new updates. So, so the team at LangChain, of course, they were receiving some feedback from the community. I can remember there were a lot of things going on social media about LangChain is not good for production and stuff, a lot of things. So, of course, using now this feedback and some of the lessons that they had learned on building LangChain, they decided, because now LangChain was not production ready, they were looking for a way to build something that either update LangChain to make it production ready, or adapt an existing architecture or framework and build a production ready library. So what they did was of course they explored some existing architectures, algorithms, but they found that most of them were not designed, or were not designed for the current age of AI on LLMs. So the question was, should they build something new? Should they adapt something that exists? And what was the need of doing all this? So some of the reason why this was necessary is because, of course, LangChain was not production ready. LangChain, that means there was a need for a production grade. Then, of course, they were interacting with so many customers, and they had seen some of the issues that developers are facing. And some of these issues, for example, was when building an AI application, an AI application, you need to consider the latency. Maybe let's say you're building a workflow that has 8 steps, then now the workflow fails at step 9. You have now to rerun the entire workflow from step 1 now to step 10, which means this is expensive, costly. So they needed also, there was a need of a way, like if the workflow fails at step 9, we can run only step 9 without rerunning all the other steps. So these were some of the things that made them to build LangGraph. So that means that LangGraph was a different I can call it ecosystem or a different architecture to solve whatever they had faced with LangChain, and also to add some new features that they felt were necessary with building the agentic application. Then in 2025, that is almost another 1 year after LangGraph, there's now so many model providers started supporting the multi-model. That is, the LLM could support images, text, PDF, and stuff. So LangChain also adopted this. But of course, before LangGraph, they they built Langsmith to help with observability and evaluation. And when they were building LangGraph as well, that's when now they did the LangGraph Studio. So we are going to reference this history a lot as we go through some of these updates, so that we are able to see what's the difference, what has changed, and yeah. Okay, I don't know. I think I'm missing something there, but it's okay. Okay, so so as I have said, LangGraph was an entirely new architecture, and so LangGraph was built to resolve some of the issues that they were facing with the community feedback, and some of the features that they felt that were necessary when building these applications. And one of the main things that they wanted to focus on is the developer experience. They wanted a framework that a low-level framework that could provide the developers with low-level orchestration when building agents. That is, you are able to define your workflow the way you want, the way you want it. There are no predefined step of how you should do it. You have the framework that is providing the orchestration to the different and abstraction to the different models. Then you decide how your workflow should look like. But over the years, I can say that we have seen kind of two. I can see two main categories when building agentic application. That is the workflow, the workflows. That is, a workflow is where you can have step one, then step two, step three, then step four. Then you have an agentic loop, an LLM with access to some tools. Then the LLM decides either to call the tool or just to respond directly to the user. And so that has evolved, and with LangGraph now you could be able to build your own React agent or build your own entire workflow. But you find that with most simple applications, you build or when you're starting to build an application, of course you'll start with a simple React. What I mean by React is you have a model, then you bind some tools to that model, then the model results with the tool, deciding that to call them or not. So to avoid that repetition and to give the developers that abstraction, they built a wrapper that was create React agent that you could import from LangGraph pre-built. But now this from here, that's where now we are going to start. We'll see now the changes, the new updates, how they have affected the two frameworks. So, for example, from this code, you can see that this is before. If you wanted to create a React agent, we are importing the create React agent wrapper from LangGraph. Now, with the new update, you will notice that we are importing the create agent from, actually they have renamed this the create react agent to create agent and moved it from LangGraph to LangChain. So what does this mean? This means that currently LangChain is running on the LangGraph runtime, because LangGraph was a new rebuild. So now LangChain is running on the LangGraph engine currently as we speak. So this means that now building agents with, for example, such a simple agent with LangChain, you are accessing the capabilities of LangGraph. Actually, this will create a workflow behind the scenes. That means that you are accessing the LangGraph power without having to build or write a LangGraph code. So what happens behind the scenes is that this will not spin a different LangChain instance. It will actually be running on the LangGraph engine behind under the hood. So that's one of the updates. They have moved the create react agent from LangGraph to LangChain. So this means that they are kind of now separating the two things, because when building an agentic application, you can either build a workflow or build an agent. An agent, I mean an LLM. You bind that LLM with tools, then you have that loop. Then a workflow is where now you can have multiple steps. Let's say, for example, you have step 2, step 3. So they are kind of trying to separate the two. So to create an agent, now you use LangChain. To create a workflow, you use LangGraph. Then whatever you could do now with LangChain before, it's kind of being deprecated, but they have moved that to LangChain Classic. So if you want to access anything to do with document loaders, a lot of packages, I'll share a link for that. It has been moved now to LangChain Classic. It is still being supported for the application that are using LangChain for backward compatibility, but I think soon that will be deprecated. So that's one of the updates. And the update here is that we have React agent to create React. But now, if we look at this create agent wrapper, you'll notice now it is easier for me to spin an agent, but now I don't have control of the agent, because to build an agent, I need the LLM, I need the tools, I need the prompts, I need maybe the state, because it is running on the LangGraph runtime. I need to manage the state and other stuff. So what have they done? So before we get into some of the ways how you can now be able to easily like do your own sorry, do your own customization. For example, you want to update the prompt, either you want to update the tools or customize the tools, either you want to customize the model. Before we get into that, I'd like to introduce the concept of runtime, so that as we are handling the other parts, we already understand what is runtime. So back again to LangGraph and LangChain. LangChain is now currently running on the LangGraph runtime. That means it is accessing the LangChain engine under the hood directly, and LangGraph exposes a runtime object which they're calling now the runtime, which is a class that now you can hook into the React agent. Then you can access the runtime on your tools, middleware, the prompt, anywhere now you want on this agent. So this now gives you the capability to access or to customize your agent the way you want. Because now, if you're using this wrapper without such features, it means that yes, you will be able to build an agent, but you can't be able to customize the entire thing. So yeah, runtime provides a dependency. Instead of hard coding the values or using the global state, you can inject runtime dependencies like database connections, user IDs, and configuration. So if you have been working with the LangGraph, you will notice that for you to be able to pass this this runtime or context information, for example, the user ID, database configuration, maybe you want to do some auth, yeah, we usually use the configurables. But now with LangChain, we are using the runtime to pass the context. And for example, in this example, you can for me, okay, let me use this one. Let me use this example. But you'll notice that we are declaring now the runtime class here. Then when invoking the and I'm passing the runtime my context variables. And if I want to access that, for example, in a tool, I just need to have the runtime argument decorator like of type runtime of type runtime. This way, now my tool. This means that my tool is able to access the runtime, and I can be able to access these context variables. So that's another update. So in LangChain, you are not passing configurables. Now you are dealing with runtime. That's another update. That's another thing you need to know if you're building with LangChain. So this is an example of how to use runtime inside a tool. Let's say, for example, let me add something else. So the runtime exposes the context. It exposes the store, that is the long-time storage. Then it exposes the stream, right? If you want to stream anything, let's say, for example, from the tool. So in this example, we have a tool. Then to access for example, the user ID, you want to fetch maybe some user information from the store for a given user, and that as a context, as a context. So you access the user ID using the runtime context. Then you can be able to check the store because we have said the store is the store, the long time memory. That is, you can connect it to a Postgres, your MongoDB. Then if you want to do any operation or fetch any data from that MongoDB or Postgres, you can use runtime because runtime provide access to the store. So that's another example. So if we go back to this agentic loop, you'll notice one of the disadvantages with this, we said that it is so hard for you now to customize. But and some of the ways they have done to enable the developers to customize is first the runtime, then we have the middleware. So the middleware a more tight control of what you can do inside the genetic loop. So if we look at this diagram, for example, you will notice this is the model, this is our tool, then you have the result, this is where the user can send the request. So with the previous React group, like we didn't have the before agent, before model, there are tool, there are model, after model, after agent. But we had I think they were called I think pre-model hooks and post-model hooks. Those are the hooks. Now if you wanted to customize anything before the model and after the model, you can use the pre-model hooks and after the model hooks. But now with the LangChain version 1.0, um, they are moving now they are moving now from the hooks now to they are moving from that now to they are adopting the middleware concept. So with the middleware concept, it provides different hooks. So we have the before agent. So this is why now you can be able to customize the request before the agent. For example, connect to a database or do some maybe sanitize your data before the agent. So you can use this for guardrails and other stuffs. Then we have the before model. So the before model, that's also a hook that is executed before the model. So you can use maybe this to customize the prompt, the LLM, and the stuff and other stuffs. Then we have the wrap model call, similar to before model call. Then we have the after model hook that is executed just after the model is called. So let's say, for example, you want to do some manipulation that before the tool is called, you can do that on the on the after model hook. Then we have the wrap tool call. So the wrap tool call, in case you want to handle some tool errors or do any customization on your tool before the tool or after the tools are called, you can use this wrapper. Then we have the after the agent hook that you can do anything. You can use this as well for output guardrails to sanitize your data before um, the response reaches to the user. So, and just to add on something on this, there are two types of media. So we have the node style, what we see here, and also there's another class called there's a class-based middleware where you can define your class. Then you say that class define some hooks. Then you can attach them to the React wrapper. Then based on either it is based on the whether it is before or after the model hook, it will be executed accordingly. So here is another example of, for example, dynamic prompt. So dynamic dynamic prompt, that's a hook. So if, for example, you want to customize your prompt, so dynamic prompt, it's a before model hook because it is executed before the model, because you want to customize your system prompt before the model is executed. So you use the at dynamic prompt decorator, then you have your system prompt function. You can see from this, we are also accessing the runtime. That's why I introduced runtime before all this, because I felt it will come in handy. So we are also accessing the username from runtime.context.username. And when invoking the agent, you can see that we are passing the context, the username. So that means then we define the runtime context class, then pass that to our React agent. Then now we have the middleware concept. If you want this to be applied, you just pass that middleware to the agent. Then agent will use the hooks to check if this is a before or after model hook, then execute it. So you'll notice now that runtime is very important because you're using it now to customize your tool or to customize how you want your tool to run. That is one, and also to when accessing the middleware, like you can access the runtime inside your middleware, so that means you can do your own manipulation on whatever you want inside the tool at the middleware. So runtime is very important, and the middleware as well is very important. So then we have so if I go back to we can see that on 2025 most of these models started supporting multi-modality. That is, they can support they can do reasoning, they can process, they can return images, text, and even some of them, like most of them, even currently, they're supporting server tool calls where they have some natively built tool calls, for example, the websites, code interpreter, and others. So this means that now the response that is coming to the user is somehow different. So to explain this, we have four different types of messages that you can send to an LLM. So we have the AI message, we have the human message, we have the system message, we have the human message, the AI message, then we have a tool message. Yeah, as a user or as a user of an application, you may want to send a PDF or an image to the LLM, then get the result. So most of these LLM providers already support that. So that's why now the standard blocks or content blocks comes in. Then, if you are getting the response from the model, let's say for example we are using OpenAI, and maybe we are using which model, maybe 5 nano. It will read data, and you may want to show that on the user interface. You may prompt it to return an image, so that means on the message content, you expect that maybe to get a base 64 string or something. But now the issue with the previous content property on the message, because the structure of the message on LangChain is we have the role of the message, that it can be a user message, it can be an AI message, on a tool message, or a tool message, and we have the fourth one as well. Then we have the content of the message. If it is a human message, this means that the message that you're sending to the LLM. If it is an AI message, this means that the response that is coming from the LLM to the user. We have the content. But now with the current updates, with the multimodality and stuff, you find that if we are returning, if the LLM is returning a response back to the user, the content of the message has changed. It may have it can have the reasoning data, it can have some images, maybe the code or the website. So the content blocks is trying to solve that issue, and how they're doing it is that they are providing a standardized way of doing this. So, and the reason they are providing a standardized way is because you find that with different providers do different things. For example, for Anthropic, I think, for Anthropic, they return thinking. If it's a reasoning tokens, like you can see, you want to display that the reasoning, you know what I'm talking about, the reasoning, whatever, text to the user, they return that on the API as thinking, but OpenAI returns it as reasoning. So for you as a developer now, if you're interacting with and you want to switch between these different models, you need to handle them differently. So the standard is providing a standard way for you to access this type of content. So I don't have to know like this provider is returns this data in this manner, or I don't need to know about that. All what I need to understand is the standard block by LangChain, then I'm good to go. So this is an example of if you don't have the standard block, I have to access the message content from the response. You can see the response. That means that's the AI response. Access the content, then the get type, then get the type. If it is reasoning, that means if it's OpenAI, get the reasoning tokens or string. If I'm using Anthropic, I have to handle that. If type text, return that text. If type image, if type video, if type audio, like I have to do that. But now with the standard, with the content blocks, I only need to access the response dot. Now notice the difference. Notice the difference. Accessing response dot content, I'm accessing response dot content blocks. Then, if I want the reasoning block, I just access the reasoning. If I want the direct string, maybe we don't have reasoning, we don't have multimodal, whatever, the image, the audio, I just access the text direct. So that's another update. Or question, maybe we have some add. Okay. Okay. How we can use? Mm-hmm. Yeah. Mm. I don't think I've gotten your question clearly. So, mhm. For example, the blocks, uh, okay. So an example where you can, in real life scenario, where you can use content blocks is, let's say, for example, you're building an AI application where you want, maybe when a user ask a question, you want to show the reasoning steps. You want to display to the user the reasoning step, what is being done. Just assume like the way ChatGPT does. You ask a question, you're able to see thinking. If you expand that, the whatever, you're able to see the thinking token. If most of you are using Cursor, you'll see before it does something, it reasons, it plans. So in real life, if you want to do such things like show the reasoning token on the UI, that's when you use, for example, the reasoning, whatever is being displayed here, the reasoning token. If you want to handle your, for example, your document, currently you don't have to chunk take that, like store that in a vector database, then start doing that. You can just upload the document directly on OpenAI. Then the model will read that document, then it can answer that uh, whatever is on that document based on your question. So what you can do is take that document, maybe upload it on somewhere, maybe let's say S3. Then using now the content blocks, let's say, for example, we are sending a message, because now this applies to both when we are sending the message to our application and when we are getting the result back. Let's say now in this example, we are sending the message now to the application. So you will send a message with a content block of type, maybe I was explaining about the PDF. Yeah, maybe of type. Is it? No, no, not sure. Let's open the documentation and see. But say, let's say for example, we are going to send a content block of type image. So there are many types of content blocks. So you can see from here. So we have the core, which is the text. If you want to